Section 3.3, the chain rule. This is the very last rule in our list of basic differentiation rules. So this is rule number 7, the chain rule. This deals with the composition of functions. So chain rule. If you have a function f, which is a function of a different function g, so if you have f of g of x, you have an outer function and an inner function, then the derivative y prime, which we also use this notation, dy dx, same thing, is equal to f prime of g of x times g of x, g prime of x. So what this rule is saying is that if you have a function within a function, you take the derivative of the outer function first, keep the inside function intact, and then you multiply it with the inside function, its derivative, that is. So, for example, if you have y is equal to x cubed plus 5x squared, the whole thing raised to the third power, then the derivative 3 comes down. It's like saying you have something cubed, u cubed. The derivative of u cubed is 3 times u squared. So you don't do anything to the inside function. Okay, so this is the inside function, the g. You don't do anything to it. You just take the derivative of the outer function. F is the outer function, that's a cubing. So 3 comes down, this stuff squared, times, then you do the derivative of the inside function. That goes in here in parentheses. So what's the derivative of x cubed? That goes here, 3x squared, plus the derivative of that is 10x. Now you might say, well, why is the chain rule the way it is? Well, let's do the same problem using a different method. So you have y equals x cubed plus 5x squared, the whole thing cubed. We'll break it down as x cubed plus 5x squared times itself 3 times. Okay, so you have 3 copies of that. If you were to use a product rule, this is f, this is g, this is h, you would take the derivative of the first, 3x squared plus 10x, and then you would copy the other 2 as they are. Okay, so you have 2 copies of these 2, that's a squared. So that's the first function's derivative. Then you keep these 2 as they are, and you take the middle term's derivative. So you get the same thing, really, 3x squared plus 10x, and then you get x cubed plus 5x squared squared. And you do it one last time to this piece, keeping these 2 as they are, and you get the derivative of that, 3x squared plus 10x. So essentially this is the same as this, which is the same as this. If you add a plus a plus a, it's 3 of that a. So it's 3 of x cubed plus 5x squared squared times 3x squared plus 10x, which totally matches what we had before. So you might wonder, why do we need the chain rule if we can just break it down every time? But it won't be the same. It won't be as much work if you use a chain rule, especially if your exponent is a huge number like 100. You don't want to write this out 100 times. Or even worse, if the power was a fraction, then you can't do this at all. And the fraction happens if you have square roots. So that can be a second quick example. If you have y is equal to the square root of x squared plus 10x, then what you have to do here is rewrite it as x squared plus 10x raised to 1/2. This is your outer function, and this is your inner function. So the derivative, it's like saying it's something raised to half. The derivative of u to the half, it's half u to the negative half, so it's half minus 1. But you keep the inside as is, but then later you multiply and take the derivative of the inside, and it goes in this spot as 2x plus 10. For this to make sense, for you to be good at this, you simply have to do a lot of practice problems. So the worksheet has many problems. It's right here. We'll zip through all of them. You might want to pause and do some on your own and then check with my work, just to be sure you're getting this without just watching me. So here's the first one, f prime of x, outer function, this is u to the 7, 7 u to the 6, so nothing happens in there. times, you go inside, negative 1 is the derivative because that's a constant. That's negative, there's a 1 there, it's a linear term. Okay, so this is the answer. You could multiply the outer numbers, negative 7, just to clean it up a little bit. And there it is. For the next one, g prime of t, the 6 is the outer function. It comes down, so it's 48. All this raised to the 5th power. This goes down, but don't change the inside. And then you multiply it with the derivative of the inside function, which is just 4t cubed. The next question, g prime of x, now because this is a constant multiple and this was a constant, we didn't have to use a product rule. Okay, that's just rule number 2, constant multiple. So 11 comes down, 22 times 3x squared minus 2x raised to 10, go inside, 6x minus 2. Okay, hope you get the idea here. F prime of t, bring the negative 3 down, so it's 2/3 times negative 3, keep the inside as it is, negative 3 minus 1 is negative 4, then you need parentheses, go inside, 10x plus the derivative, not x, 10t, whoops, plus the derivative of that is just 1. Let's do this. F prime of x, the negative 7 comes down, all of this will remain untouched, minus 8, because it's negative 7 minus 1. I'm going to copy all this down. Then you go inside, parentheses, 21x squared plus 4x minus 3, the derivative of that is 0. Okay, now, slight little twist. This is on the bottom. You could use the quotient rule and then the chain rule, or you can bring this up and write it as 3 times 2x minus 11 raised to negative half, and then take the derivative. You still need the chain rule. This negative half comes down, makes it a negative 3 halves, 2x minus 11 times raised to the negative half minus 1, that's negative 3 halves. When you go inside, you get 2. If you want to simplify, the 2's do cancel, and then you can rewrite it. How hard does this get? Let's take a look at this question. Here we have a quotient and a big power, so you have chain rule and quotient rule, but the first rule you have to use is the chain rule because you need to deal with the 100 power. So f prime of x, this is like u raised to 100. The 100 comes down, u is raised to 99, so the inside is untouched, times, now you need to take the derivative of that. The derivative of the top, 1, times the bottom, minus, keep the top, derivative of the bottom is 1, all over bottom squared. So we use the quotient rule after the chain rule. Now this is going to show up in your homework as well. I want you to pay attention to how s's look like 5s, so be careful when you type it in. I'm going to first go inside here and rewrite that as s to the negative 1 raised to 3 halves. So f prime at s, 3 halves comes down, that's the outer function, keep the inside as it is, 3 halves minus 1 is 1 half, so it's s cubed plus s to the negative 1, times, you go inside, it's 3s squared, the negative comes down, and then it's s to the negative 2. Okay, so you might want to rewind that and watch it over again, it's a little tricky. Now, the next question. This is one piece, this is one piece, you need to use a product rule. So this is, let's call it a times b. So g prime of x would be, take the derivative of the first, a prime, keep the b as it is, a prime, keep the b as it is, plus, keep the a as it is, take the derivative of b. Product rule. So a prime would be just 6x. Okay, that's a simple one. Copy down the second piece, plus keep the first. For the second piece now, we need to use chain rule because you have a function inside and a function outside. The 4 comes down, 2x minus 3 gets cubed, then you go inside and you get a 2. The derivative of the inside is 2. You can clean this up a bit. Okay, that's just 6x times 2x minus 3 to the 4th. These are all straight terms. You can multiply. 4 times 2 is 8, times 3 is 24, x squared, and then that one we don't need to go any further with that. One last example, another product rule, f prime of x. You have a function times a function. Take the derivative of the first, 5 comes down, 3x squared plus 2 raised to 4, go inside, you get 6x. Keep the second as it is. There's a lot of things to remember here. Plus, keep the first one as it is, times the derivative of the second, 3 comes down, 5x plus 6 gets squared, times, go inside, and you get 5. Alright, try the homework. Let me know if you have any questions.